Okay, so we're trying to find the distance between two given points. These will be coordinates, and a big test here is being able to actually label these coordinates correctly. So we've got this lovely picture with this point here and this point here. This is 6, 1, this is 5 and 1. All right, so these 2 points A and B. We want to find out what the length of the line that joins these two up is. So from here all the way up to here. What is the length of that line? Now you've all learnt how to find the length of this line, even though you may not know. You can use your intelligence to actually build a triangle. Right? And that's a right angled triangle. So what would we use to find the length of that slope? What's that thing we learnt? Not trig, but the other one? Pythagoras, right? The slopey side equals the sum of the other two squared. That's fine. So in this case, we could work it out really quickly. We've got 6, take away 1, that's plus 5. We've got 5 to there, and the next one, this one's 6. So 5 and 6, and we need to find that one. And we could do it by Pythagoras. But that is not the test. You may not get a picture, all right? You are more likely to just get coordinates, and they may not be little coordinates. They might be really big coordinates. They might be 3 digits or even 4 digits, and you have to be able to do it. So what we do is we're doing exactly Pythagoras, but we've got a formula, and the formula says that the distance from AB equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, that's our formula. So we need that. We're going to use it today a lot of times. So, what does it all mean? It just says that this squared equals that squared plus that squared. That's Pythagoras. But we've put everything, so we haven't got the square on this side, we've put everything over here in a formula. So, this assumes for us that A and B, so A is 1, 6, and B is 5, 1. Remember, always the across first, so 1, 6, and 5, 1. Oh, negative 5, 1. Okay. Negative 5, 1. Those are our 2 points. The second thing we are going to do is label them with these funny letters. So, X is the first letter, first one. So this is X, this is Y, this is X, this is Y. Yesterday somebody asked me, does it matter which is which? No, it doesn't, again today. But we're going to call one of these the 1 point, and one of these the 2 points. So this is the second point, this is the first point. If I decided this was the first point and this was the second point, I would get exactly the same answer. Okay? So there's no tricks about which one is which. Now we have to fill in this formula and calculate it correctly. So we want to say that the distance from AB equals the square root of. See how long that is? That says that it's the very last thing I do. Alright, so if I'm putting all of this in my calculator, which I don't really want you to do, but you can, because it's likely you might make mistakes along the way, I would have to put a bracket here and a bracket here to say everything in here is under that square root. Alright, that's what that line indicates. Now, I've got an x2, that's negative 5. I've got minuses this time. Minuses here, plus here. Alright, yesterday it was plussing, today it is minuses here and plus here. Really, really important. That's the biggest mistake people make. So minus 1 squared plus y2, 1, and you must have these the right way around. You can't muddle, this one can't be x2 minus x1 and y2, y1 minus y2. Must be x2 and x1, and y2 minus x1 and y1. Okay? It's really important, this formula. 1 minus 6. Okay. So a certain amount of this you can do in your heads, but if you don't feel confident, you need to use your calculator, go right ahead. Better to get it right. Or you could use your head and your calculator. That's also a good skill. So here we've got minus 5, take away another one, that's minus 6 squared. Here we've got 1, take away 6, that's minus 5 squared. All right, and we're square rooting the whole lot. So the next thing is negative 6 times negative 6 is 36. 5 times 5 is 25. We're square rooting that. And we're square rooting 61. Now, if we were actually measuring this in miles or something, it's an actual distance that we're representing. We wouldn't really want it to be called the square root of 61. So if that was our answer, algebraically, we can leave it like that. It is, the square root of 61 is the perfect answer. The moment we put this in our calculator, we are approximating the answer. So when we put it in the calculator, I'm going to make a guess, I reckon it's 7.8. Does anybody put it in? Square root of 61. Someone tell me what it is. Is it? What's the next number? Perfect. Yes, got it right. It's one of my lovely fun games. 7.8 to 1 DP, decimal place. All right. So that's, if I was actually saying it's in miles, I would say 7.8 miles, because the square root of 61 miles doesn't mean much to people. All right. But if my example was not in miles, it was something more abstract, then square root of 61 is the perfect answer. This one has a whole lot more numbers after it. Okay? So, that's one way of writing it. You may prefer to write it like this. Let's say we've got k is negative 2, 5, and L is 4, 3. All right? If we're finding the distance of KL, we could write it like this. The distance of KL squared, and then we don't have to write the square root everywhere, is, now, going from the beginning, negative, so I'm going to label them first, so I know which is the what. This is x, this is x, this is y, this is y, this is 1, this is 2. Okay. Right, x2. 4 minus x1 minus negative 2 squared plus y3 minus 1, 5 squared equals 4 plus 2, 6 squared plus 3 minus 5, negative 2 squared. We need that bracket around the negative 2 because if we put negative 2 squared in our calculator, it will tell you the answer is negative 4. But this is negative 2 times negative 2. That we know, 2 negatives make a positive. We know the answer to this is 4. But if we put it as negative 2 squared, it's saying negative 2 squared, please. What's 2 squared? 4. Negative 4. That's not the same thing. So remember brackets here. So we've got 36 plus 4. Now we need to rewrite this as the distance because we're going to drop the squared and square root this 40. I'm going to leave it like that because that's the perfect answer. I don't need to approximate unless I'm told to, really. Are there any questions? All right, so being very careful with our working, guys.